Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, life must go on no matter what in this world. Okay, my topic for my discussion for tonight. Okay, this will be a random topic, and this will be an additional topic on my playlist, and it falls under the so-called long video format. The topic is actually differential equation. We are saturated on YouTube, the lower math topics, and it's always a redundant thing. It's not nice to say. So if you would like to become a software engineer, okay, better learn differential equation. Okay, let's proceed. My subject matter for tonight will be a random topic, and this falls under the so-called study of differential equation. Oh, to illustrate differential equation, we got a problem here. We are given an algebraic equation y equal to 3x cubed plus 2x squared plus 3x plus 4. The problem is just asking find d cubed y all over dx cubed, and d should be equal to. This is how we read this one under the so-called study of differential equation. D cubed y over dx cubed, and what will be equal to. What is actually d cubed y over dx cubed? Okay, before I will try to bring out the solution of this one, we'll try to bring out some concepts on the study of differential equation. If we are given y equal to this function here, okay, if we try to take the derivative of the given function y with respect to x, meaning the derivative with respect to x of y, okay, that will be equivalent to actually dy dx, okay, and the other equivalent of this one under the study of higher order derivatives, under the study of differential equation, that is just designated y single prime. Okay, so at least we now know where dy dx emanates. It is actually the derivative with respect to x of any given function of y, that's dy dx. And that is equivalent to y prime. Okay, let's try to take again the derivative of the first derivative. So the derivative with respect to x of the first derivative, if we try to simplify this one under the study of differential equation, this could be simplified to d squared y over dx squared. Okay, this is referred to actually as a second derivative, and the other equivalent of this one is just actually y double prime. Okay, so at least we now know where the value d squared y over dx squared emanates. It was actually brought out by using or by taking the derivative with respect to x of the first derivative. Next one. If we try to take the derivative of the second derivative, that is the derivative with respect to x of d squared y over dx squared. If we try to take the simplification of this under the study of differential equation, this should be d cubed y over dx cubed. This is actually the third derivative. If this is with the power 3, okay, is third derivative. And the simplified equivalent of this one is actually y triple prime. So what is being asked here is actually this portion here. Okay. So this d cubed y over dx cubed is actually y triple prime. I will just take the derivative of the given function 3 times, and what will come out will be the third derivative of the given function, and in simplified form that is actually equivalent to y triple prime. Okay, let's bring out the solution. The given function of y is actually equal to 3x cubed plus 2x squared plus 3x plus 4. If we try to take the derivative with respect to x of y, that will be y prime. It is this one. So y prime, we proceed now with the differentiation of this one. Okay, for those of you who are just fond of the lower math, this is now differential equation. I will explain this one as concise as possible. The first one is a constant and a function which is x cubed. The second one is a constant multiplied by a function which is x squared. The third one is a constant multiplied by a function which is x. And this last part is actually pure constant. So we will be taking the derivative by using a constant multiplied by a function. So the first one, y prime, will be 3. We segregate the 3 times the derivative of x cubed. It will be under the power formula. 3x squared multiplied by 1. Okay? The derivative with respect to x of u to the n will be equal to nu raised to n minus 1 times du dx. That's the one we are using for these ones. Okay? So the power here is 3. Decrease in power by 1, this will become x squared. And the derivative of x with respect to itself will be 1. Okay? Next one. Again, a constant multiplied by a function, and that function is a quadratic equation, right? So it will be that constant. We don't touch the constant. Okay? This falls again under the power formula. The power will be 2. Decrease in power by 1. That will be x raised to 2 minus 1, which is just simply x, times the derivative of x with respect to itself, this one. The third one, again, it falls under the product of a constant times a function, and that function is just a simply linear value x. So we don't touch the constant, it will just be simply 3 times the derivative of x with respect to itself will be 1. And the last part, for those of you who are just fond of the lower math, this is now higher differential equation. The derivative with respect to x of any constant, and b should be equal to 0. Okay? First differential equation that we use, second differential equation that we use, okay? It's a good problem already because we have encountered two differentiation formulas. So the derivative with respect to x of 4 is a constant, and this should be equal to 0, so this is plus 0. Simplification, this is now algebra. This is where your knowledge of algebra will come out. If you don't know how to simplify, you're gone. Okay? We multiply all the constants. The 3 times 3 will be 9 times x squared. 2 times 2 will be 4 times x plus 3 multiplied by 1, which is 3 plus 0. So the first derivative is actually this portion here. This is as simple as that one. That's differential equation. Higher mathematics. It's not algebra. It's not trigo. It's differential equation. This falls under higher order derivative. Okay. By using the second concept, if we try to take the derivative with respect to x of the first derivative, what will come out will be y double prime. Right? So meaning to say the derivative with respect to x of y prime will be equal to y double prime, or that's just equivalent to d square y over dx square. I don't want to use this one because it's a tedious thing, right? It's a long form, and I could simplify my solution by just simply using y double prime. So if I will try to take the derivative of the first derivative, instead of writing d square y over dx square, I will just write y double prime. Okay? Again, if we try to inspect this one, 9 times x squared, it's a constant multiplied by a quadratic equation. Second one, it's a constant multiplied by a linear equation. This is pure constant. So still, we will still be using this one. Okay, and this one. So y double prime will be 9. We don't touch the constant. And the derivative of 2x squared, it falls under the power formula. The power will be 2 times x, decrease in power by 1. Okay, times 1, the derivative with x with respect to itself. Next one, we don't touch the 4. we will take the derivative of x. And the derivative of x with respect to itself is actually 1. And the last part, it falls under the derivative of a constant. So this will be 0. Again, simplify by using your knowledge of algebra. Just be sure that the simplification is correct, because if you are wrong in the simplification, okay, the value of the second derivative will be wrong. And of course, the last part, which is your final solution, will be wrong. So just make sure your simplification is correct. So y double prime, 9 times 2 will be 18 times x plus 4. So this is the value of y double prime, the second derivative. Okay? And the final answer, the one we are looking for, if we try to take the derivative with respect to x of y double prime, that will be y triple prime. Y triple prime, or just simply d cube y over dx cube, and that is y triple prime. That's the one being asked. So y triple prime now, again, inspect the second derivative. The second derivative, this falls under a product of a constant times a function, right? And this is a pure constant. So we will still be using this formula here, okay? And this formula. Okay, so y triple prime now will be 18. The derivative of x with respect to itself is 1. And the derivative of 4 with respect to x, it's a pure constant. It will be 0. So this is plus 0. Simplifying. Y triple prime now, or that is actually equivalent to what is being asked, in which I emphasize the concept that d cube y over dx cube is actually y triple prime. And the final answer should be 18. So the third derivative of y with respect to x, this is actually equal to 18. So this will be the answer. As simple as that one. Okay, this differential equation, they use this one in the so-called formulation of softwares for anything in this world. Okay? It could be a projectile maybe, or some other things. But the application of this differential equation is actually in the software, in the so many applications in this world. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.